In this problem, we're asked to find all the zeros and write a linear factorization of the function. And we are allowed to use Desmos, and the reason is, if we were to write out a complete list of all the possible rational roots, that list would be very long, and it would be possible for us to check everything, but in the interest of time and efficiency, we'll use technology to speed up this process. So what we're going to do is graph this function. So if I look at its graph, I see that I have zeros at negative 3/5, negative 0.6, and at 5. So I'm going to write that down. And then what I'm going to do is synthetically divide the coefficients of the polynomial first by 5, and then I'll take the coefficients of the depressed polynomial and synthetically divide them by negative 3/5. That will give me the coefficients of a depressed polynomial, which is a quadratic, and I'll be able to use the quadratic formula to find the roots of that polynomial. Okay. So I bring down 20, I multiply and add, multiply and add, multiply and add, I multiply, and when I add I get a remainder of 0. Then I'm going to take the coefficients of this polynomial, synthetically divide these coefficients by negative 3/5. So I bring down 20, I multiply, combine to get negative 60, multiply, combine to get 65, multiply, and when I add I get a remainder of 0. So I want to find the roots of this polynomial. In other words, I want to find the solutions to this quadratic equation. So first, I make this easier by factoring out 5. And then I'm going to plug 4, negative 12, and 13 into the quadratic formula. So when I simplify, I get 12 plus or minus the square root of negative 64 over 8, which is 12 plus or minus 8i over 8, and that simplifies to 3 plus or minus 2i over 2. So I'll start by writing out the roots. So the real roots are negative 3/5 and 5, and the complex roots are 3 plus 2i over 2 and 3 minus 2i over 2. The factorization I'm going to write in a few different ways. So first, let's think about the quadratic. So I factored out 5, and then when I factored this polynomial, the factors were x minus 3 plus 2i over 2 and x minus 3 minus 2i over 2. So that's the factored quadratic. And then the other two factors of the degree 4 polynomial are x plus 3/5. I'm going to make space. And x minus 5. So if I wanted to only use integers and no fractions, there's some things I could do here. I could multiply 5 by x plus 3/5, and then that would give me 5x plus 3. And then what I can do is I could take each of these factors and multiply them by 2 over 2. So if I multiply these factors by 2 over 2, I'll show you down here what happens. That would give me 2x, and then these 2's would cancel, and I would get minus 3 plus 2i. So if I do that for both of the factors with complex roots, I would get 2x minus 3 plus 2i and 2x minus 3 minus 2i. So what I want to point out is that these factorizations are equivalent. It's important to understand why, and it's important to recognize equivalent factorizations, especially if you were picking one option out of many options in a multiple choice question. But if you're just solving this problem, either of these factorizations would be acceptable.